Hello, welcome back to Mrs. Torres' YouTube channel. Today we are going to be introduced to parabolas. A parabola is the graph of a quadratic. So it's going to look like either an upturned U or an upside down U. Let's use kind of the most basic quadratic, y equals x squared, and graph our first quadratic. We're going to do this by making a table of values. I'm going to choose a few x's for you. And then we need to figure out the y value. So let's say -2, -1, 0, 1, and 2. You always want some negative, some positive, and throw 0 in there. So if x is -2, -2 squared would give me 4. If x is -1, -1 squared is 1. If x is 0, 0 squared is 0, 1 squared, 1, 2 squared, 4. So let's draw a coordinate plane. And let's graph our points. So our first point is -2, 4. So 1, 2, 1, 2, 3, 4. -1, 1. So -1, +1, 0, 0, 1, 1, and 2, 4. So there's all of our points in the graph. Now let's connect the dots. So that is our graph of y equals x squared. And we call this a parabola. All right, let's graph another one. And with this one, I'm going to show you some important parts of our graph. So let's try y equals -x squared minus 2x plus 3. So let's make another table of values here. I'm going to use the same x's, so let's say -2, -1, 0, 1, and 2. Now, it's going to take us a little more effort when we plug in our values here, but with some good calculator skills, it won't be too bad. So when x is -2, let's plug it in. So we would get the opposite of -2 squared, right, because we have -x squared, minus 2 times -2 plus 3. Now it's just some calculator work. So we've got -2 squared. Notice how I put the -2 in parentheses. Minus 2 times -2 plus 3. So it looks exactly how I wrote it on the paper here. And we get 3. So when x is -2, y is 3. Now, a handy little trick. Instead of typing this all in with -1 as x, what I can do is hit second and the enter button. So really we're hitting entry. That brings up the last thing that I put in my calculator. And then I can go back and just replace it. So instead of -2, I want -1 and -1. So we get 4. Let's do it again with 0. 0, 0. So that's going to give me 3. Let's do it again. Second, enter. And we're going to make these 1. So that gives me 0. And let's do it with 2. So 2 for x there, 2 for x there. -5. All right, before we graph this one, I want to show you another way to very easily see your table of values. So the first thing we're going to do is go to y equals. So we're going to hit this y equals button here. Let me clear this out. In the first y equals, we are going to input our quadratic equation. We don't need the y equals part because that's already there. So we're going to hit negative. And then to get an x, we hit this button here. It has an x, a t, right there. That will give you an x. And then we want squared minus 2x plus 3. So you should plug that into your calculator. Now, notice up here at the top, we've got y equals, window, zoom, trace, graph. We don't want to use that yet, but right above that in blue it says table. That means if I hit second and then graph, it brings up the table. So check this out. Negative 2 gives me 3, negative 1, 4, and so on. So we really have this whole table here. If yours doesn't look like that, go ahead and hit second, window. That'll bring up this. Make sure that your change in table is 1 here. If it's like 0.01 or anything other than 1, it's going to make your table look a little weird. So just make sure that it's 1. And then table start, I think you can leave it at like 10. I think that's what it defaults to. That just means it's going to start at 10, but then you can scroll to whatever number you need. So like we want 0. So there it is. So that's just a nice, easy way to make your table of values and then be able to graph your parabola. All right, let's go back to our parabola here. Let's draw our coordinate plane. And let's graph our points. So negative 2, positive 3, negative 1, positive 4, 0, 3, 1, 0, 2, negative 5, 1, 2, 3, 4, and 5. So even though we have most of our points on this side of our graph, we can kind of just use, we can just draw the other side because it's going to be a mirror image. So like that. All right, let me switch colors here. And I'm going to use a different color to label our important parts of our graph. So the first important part is this point here. Oh, before we do that, notice how this parabola opens down and this parabola opens up. Look at the difference in our two equations. Now, of course, this equation has a little more to it, but really focus on the x squared. This has a positive coefficient, right? Positive 1x squared, and it opens up. This quadratic has a negative 1 coefficient, and it opens down. So when it's in standard form like this, the coefficient on the x, whether it's positive or negative, will determine if your parabola opens up or if it opens down. And we'll talk more about that later. All right, now on to the important parts. So this dot here, we call that the vertex. In this case, our vertex is negative 1, 4. And then with the vertex, you can either have a maximum value or a minimum value. So our values are, we're really talking y values here. So our values are in the negatives, hit 0, and then it goes up here, hits 4, and then notice after that, they come down. So in this case, our vertex is a maximum. If we look up here, whoops, classroom lights just went off. If we look up here, our vertex is here, so our y values are large, getting smaller, getting smaller, getting smaller, hit 0, and then go back up. So in this case, we have a minimum. So your vertex is either a max or a min, and it all depends on how your parabola opens. So like I said earlier about our parabola being kind of like mirror images, we could draw a line through our vertex, and really we could fold this over on that line. And so half of our parabola is here, and the other half matches up perfectly through that line. We call that line the axis of symmetry. Now, the axis of symmetry is a vertical line. The equation of a vertical line is always going to be x equals some number. The axis of symmetry is always going to be x equals the x value of your vertex, because it's going right through that vertex, right? So in this case, our x value is -1, so our axis of symmetry is x equals -1. All right, there's two other important parts of our parabola here. The first is the y-intercept. So right here, it's where the graph hits the y-axis. In this case, our y-intercept is 0, 3. And of course, your y-intercept is where x equals 0. The other important value we have are the x-intercepts. So here and here. And those are when y equals 0. And so your value or your graph crosses the x-axis. We're going to talk more about how to find those in the next lesson. But for now, we just need to know what they are. So in this example, they would be 1, 0, and -3, 0. So let's think about these x-intercepts for a second. So we said that the x-intercepts are where y equals 0, correct? So if y equals 0, if we plug our 0 in here, we would have -x² minus 2x plus 3 equals 0. Do we know how to solve that? Absolutely we could. We could factor, we could complete the square, which we're probably not going to do. We could use the quadratic formula. So really, another name for our x-intercepts, we could also call those our solutions. You'll also hear them be called our roots or our zeros. So these four things are kind of like synonyms of one another: x-intercept, solution, root, or zero. They all mean, where does our graph hit the x-axis? All right, I will see you tomorrow. We will talk about how to find these things.